This is lesson number 99, uniform motion and unequal distances in Algebra 1. So let's go ahead and get started with this. Alright, sometimes you're going to start at a certain place, like I have there, and you may have one person that goes a certain distance. So we'll just call that distance of person A. We'll call him Alvin. And he gets a flat tire, let's say, on his bike, and he stops there. Alright, well, Priscilla decides she isn't going to stop and help Alvin. She's going to continue on to the finish line. Alright, let's say that Alvin finished 50 miles short of the finish line. So, this is the distance he did not cover. So sometimes you're going to end up with a problem that looks like that. The distance of Alvin was a certain amount of miles, 50 miles short of the finish line, whereas Priscilla went the whole way and won the race. Okay, so the distance of Alvin plus the 50 miles he didn't go would have been the total distance that Priscilla ended up going. Okay, so that's how we're going to make the equation, because you know, whenever you make an equation, you have to have an equal sign in order to solve it. If you don't have an equal sign, you can't solve it. So somehow we need to take information from something like that and make it into an equation that we can actually solve. Alright, so let's look at an actual example. We're going to look at example 99.1. Okay, so at 8 o'clock p.m., Achilles left camp and headed south at 20 kilometers per hour. At 10 p.m., Patroclus headed south from the same camp. If Patroclus was 50 kilometers ahead by 3 a.m., what was his speed? Okay, so where did they start? They both started at the same place. They started at their camp. There's my little tent there. Okay, so they started there. Achilles is heading out first, right? Okay, distance of Achilles. He left camp and he headed south at 20 kilometers per hour. So his rate of Achilles was 20. So we'll write that down. At 10 p.m., Patroclus headed south, and if Patroclus was 50 kilometers ahead by 3 a.m. Okay, so this is, gosh, how much time was each one of these guys on the road? Alright, so the time of Achilles, he left at 8 p.m., and the time we are looking at later was 3 a.m., so that was 7 hours. The time of Patroclus, or however you pronounce that, I mean, why do they use names like that? He started at 10, so he stopped at 3, so that was 5 hours. Okay, so what do I not have? I do not have the rate of this P guy, right? Okay, well, let's keep looking at what I have here. At 3 o'clock in the morning, the distance of this guy was 50 further than Achilles, right? Because it says at 3 a.m. he was 50 kilometers ahead. Okay? So, if we wanted to, I mean, we've got a bunch of information right here, which is good, but how do we make that into an equation? So we have to write the equation, and then we fill in the letters with that stuff. Okay, so our equation is the distance of Achilles plus 50 would be the distance of Patroclus, that guy. Okay, so now we can just start filling in information. Let's write this as RT plus 50 equals RT of the other guy, because distance equals RT, distance equals RT. Alright, so let's start filling in our letters here. So RA is 20, TA is 7, RP we don't know, that's what we're looking for, and TP is 5. So we have 140 plus 50 equals RP times 5. So this is 190 equals RP 5. Now we're going to divide by 5 to find the RP, and we find out that RP, the rate of that guy, is 190 divided by 35 is 38. Alright, so the hard part is not this stuff here. The hard part is making the equation and substituting that in and then doing the basic algebra. Alright, so let's try another one here. 99.2. Rachel, yes, a better name. Rachel has a 15-kilometer head start on Charlene. How long will it take Charlene to catch Rachel if Rachel travels at 70 kilometers per hour and Charlene travels at 100 kilometers per hour? So, in this one, we have a 15-kilometer head start. So, Rachel is 15 kilometers ahead of Charlene when Charlene starts. So here's where Rachel is, and here's where Charlene is when Charlene starts. Rachel's already 15 ahead. Okay? We're talking about the same distance eventually, though, because it says how long will it take Charlene to catch Rachel. So that means Rachel will go the rest of this, and at this point right there, that will be where Charlene catches up to Rachel. So this will be the distance of Rachel, and this will be the distance of Charlene. So my equation is going to be 15 plus the distance of Rachel, and that will equal the total distance of Charlene, right? So there's my equation. Now I make my RT for Rachel and my RT for Charlotte. And I fill in the blanks with what information I have. Okay, let's see what we've got. Rachel travels 70 kilometers per hour. Alright, so Rachel is at 70. Charlene is at 100. And let's see, what do we know about the time? Well, the time is going to be the same, right? Because, alright, so Rachel starts here, Charlene starts there. Okay, that's where we're going to start with our time. We don't care when she got 15 kilometers ahead. All we care about is the time from the time Charlotte started and how long it took her to get there. And when they got there, or when she caught up, they stopped. So this time is going to be the same. So we can, let's just make our time the time of Charlotte. So, because they're both the same, let's just make them both TC. Okay? So we have 15 plus dr, which would be rate times time, equals rate times time again, rate of Charlotte. Whoops, I need to put the rate of Charlotte. She was going 100, and then her time. Okay? So we get something like that. Alright, so let's move the 70 over here. So that gives me 15 equals 30. Then I divide by 30, divide by 30. And my time for Charlotte is 1/2. So what does that mean? That means 1/2 hour. Okay? And that's what we're looking at, is the time that it's going to take Charlotte to catch up to Rachel. Alright, I think I have enough time to do one more, 99.3. Kelly, Harry, and Janae, I don't know, Jeanette, let's just say Janae, jog around a circular track that is 210 meters long. Janae's rate is 230 meters per minute, while Harry's rate is only 200 meters per minute. In how many minutes will Janae be a full lap ahead? Alright, so if we straighten the loop, 210 meter or 210 meter long circular track, let's go ahead and just make it a straight line. Okay, so that's 210. And let's see, we have Harry. Okay, so what we are interested in is in how many minutes will Janae be a full lap ahead. Okay, so let's go ahead and erase that 210 there, because the distance of Harry is going to be some distance, and we're interested in at what point will Janae be 210 meters ahead. So at this point where Harry makes it to here, Janae is one lap ahead. One lap is 210. So we're interested in this right here. You know, at what point in time will Harry be here and Janae will be here, one lap, 210 meters ahead. Okay, so we've got the distance of Harry plus 210 equals the distance of Janae. Okay, or we're going to write it as RT plus 210 equals RT of Janae. Alright, let's see what information we've got here. Again, our time is the same, so the time of Harry equals the time of Janae. We've got the rate of Janae is 230, and the rate of Harry is 200. So we've got the rate of Harry times the time of Harry plus 210, I'm taking it off this one, equals the rate of Janae equals the time of Janae. And again, since the times are the same, I'm just going to make it the time of Harry. Just so I have one variable. Alright, and let's move this over here. So that gives me 210 equals 230 time of Harry minus 200 time of Harry gives me okay, 30 time of Harry divided by 30 divided by 30, and 210 divided by 30 is 7. So 7 is the, let me erase that, is the time of Harry. So in 7 minutes, Janae will be one lap ahead of Harry. And that's it for lesson number 99. Just follow those rules where you make a little drawing, write the equation, put the RT in for the D's, write down a list of the R's and the T's so you know what numbers go with which, substitute them in, and solve. Okay? So it shouldn't be too terribly difficult.